You ever get that feeling that nature is just repeating itself? Kind of like it finds a design it really, really likes and just keeps hitting copy paste. Well, it turns out that's not a glitch in the matrix. Today, we're diving into one of the most fascinating and honestly weirdest patterns in all of evolution. It's a phenomenon that suggests the story of life might just be a little more predictable than we ever thought. All right, to kick things off, just look at these two. On the left, you've got an ichthyosaur. It's an ancient marine reptile that lived more than 90 million years ago. On the right, a dolphin, a modern mammal. Now, these two are about as related as you are to a lizard. And yet, just look at them. Both have that sleek torpedo-shaped body, a dorsal fin on top, flippers for steering, and that powerful tail for speed. It's uncanny. So what is going on here? How on earth do two completely different animals, separated by millions of years and from totally different branches on the tree of life, end up looking like long-lost twins? This is a genuine evolutionary mystery. Well, this isn't a one-off thing. It's not a coincidence. This biological déjà vu is a super powerful force in nature. It's a phenomenon where evolution seems to be following a script. And lucky for us, it has a name. It's called convergent evolution. And this right here is the answer to our puzzle. The ichthyosaur and the dolphin look so much alike because they both had to solve the exact same problem. How do you become a fast, efficient hunter in the open ocean? They each, completely independently, converged on the same winning design. So why does this happen? Why does nature keep landing on the same answers over and over again? Well, it helps if you stop thinking of evolution as totally random and start thinking of it more like a problem-solving engine. The environment and the laws of physics, they set the test, and natural selection's job is to find the best answer. Okay, so here's how it goes down. Step 1, an environment, a niche, creates a problem. For a dolphin and ichthyosaur, that problem was catch fish in the water. Step 2, natural selection starts to favor any little change that helps solve that problem. A smoother body that cuts through the water, fins that help you steer, a strong tail for a burst of speed. And step 3, because the laws of physics, you know how water works, are the same for everybody, any creature trying to solve that same catch fish problem is going to get pushed towards that same single best solution. And this really just nails it. It's not that evolution doesn't have an imagination, it's that physics and chemistry lay down some very strict rules. And within those rules, evolution is just brutally good at finding what works. And you know what? This isn't just a biology thing. This happens with us too, with human engineering. Get this. During World War I, German and Allied engineers were completely cut off from each other. They were both desperately trying to solve the same problem. How do you mount a machine gun on a plane so it can fire through the spinning propeller without blowing your own blades to bits? And what happened? Working totally separately, they both invented almost the exact same gear mechanism to do it. Same problem, same physical constraints, same optimal solution. So the amazing thing is, once you know what to look for, you start seeing this pattern absolutely everywhere. So let's take a quick run through some of evolution's greatest hits, its most famous doppelgangers. Let's head over to Australia. It's basically this giant, isolated evolutionary laboratory. There, marsupials evolved to fill all the jobs that placental mammals, like us, filled everywhere else. And the result? You get the thylacine, the Tasmanian tiger. It evolved to look and act so much like a wolf that, look at their skulls. They are practically identical. It was a classic trick question to ask biology students to tell them apart. And it's not just on the ground. Look up in the trees. Over in Australia, marsupials came up with the sugar glider. And in the northern hemisphere, placental mammals came up with the flying squirrel. Two totally separate family trees on opposite sides of the world. Both needed to solve the problem of getting from one tree to the next, and they both came up with the exact same solution. Evolve some skin flaps and learn to glide. And the list just goes on and on. Bats and dolphins, one flies, one swims. They couldn't be more different, right? Well, they both independently came up with echolocation. Sonar. Echidnas, porcupines, hedgehogs, all over the world, small, unrelated mammals figured out that evolving sharp spikes is a great defense. And maybe the most mind-blowing one of all, the complex camera eye, like the one you're using right now, that has evolved from scratch, completely independently at least 40 different times. But of all the examples out there, there is one that is so extreme, so persistent that it's in a league of its own. Evolution is so obsessed with this one body plan that scientists had to give the phenomenon its own special name.
And that name is carcinization. It's the bizarre evolutionary tendency for crustaceans to keep evolving into a crab-like shape. Why? Because the crab form is like the Swiss Army knife of the seafloor. It's wide and flat, so it's stable and can hide easily. It's got powerful claws for fighting and eating. It's just a fantastic design. It's so good that tons of things we call crabs aren't actually true crabs. King crabs? Nope, they evolved from hermit crab-like ancestors. Porcelain crabs? Also not crabs. Evolution just can't seem to help itself. It just keeps making crabs.
Okay, so this is all really cool. But what's the big takeaway? What does all this repetition actually tell us? Well, it might just tell us something incredibly profound about the nature of life itself. Not just here on Earth, but maybe, just maybe, everywhere else too. It all leads to this huge thought experiment. Imagine you had a cosmic remote control. You could rewind the tape of life all the way back to the very beginning and then hit play again. Would you end up with something totally different? A planet of bizarre creatures we couldn't even imagine? Now, for a long time, the prevailing wisdom was, yep, totally different every time. But convergent evolution offers a really powerful counterargument. It suggests that while, yeah, the little details might change, the big picture, the broad strokes, might be incredibly similar. Because the rules of the game, the laws of physics, the problems posed by ecology, those things don't change. And that means the shapes that life takes to win that game might be way more predictable than we thought. And this is where it gets really fun, because it has massive implications for what alien life could look like. If we find an alien world with oceans and an atmosphere like ours, the same rules would apply. The laws of physics would probably push life in their oceans to evolve a streamlined, fish-like shape. Life in their skies might converge on a bird-like design. They wouldn't be fish or birds, but they might look a whole lot like them. So, in the end, convergent evolution gives us this whole new way of looking at the incredible story of life. You can think of it like this. Planet Earth is a giant stage, and on that stage, the roles, the hunter, the swimmer, the flyer, they all stay the same. It's just the actors filling those roles that change over time. The play itself, written by the laws of the universe, just keeps on going.